Hi everyone. In this video, we will see what is magnetically coupled circuits, self-inductance and mutual inductance. So first, what is magnetically coupled circuits? When two circuits are placed close to each other, such that a magnetic flux produced by one circuit links with both the circuits, then the two circuits are said to be magnetically coupled circuits. The magnetically coupled circuits consisting of coils or inductors, these are all called coupled inductors. When two or more coils are placed very close to each other, then the current in the one coil affects other coils by inducing voltage in them. Such coils are said to be mutually coupled coils. Such induced voltages in the coils are functions of the self-inductance of the coils and mutual inductance between them. Self-inductance. See, look at the circuits. In the circuit, the voltage applied is denoted by the letter E and current flowing through the coil is I. The number of turns is denoted by N and the flux produced is represented by the letter phi. The self-inductance of the coil is the flux linkages produced in the coil per unit current in the same coil. So, if flux linkages is produced in a coil due to the current flowing in the same coil, then it is called self-inductance. If the current I through the coil changes, then the flux linkages flux also changes. According to Faraday's law, an EMF is induced in the circuit. So that is called Faraday's law of electromagnetic induction. This EMF is to rate of change of flux linkages, that is induced EMF E directly proportional to the d phi by dt. d phi by dt means rate of change of flux linkages. And proportionality constant here is n, number of turns. E is equal to minus n d phi by dt. This minus denotes Lenz's law. Here where E is the induced EMF, n is number of turns of the coil and d phi by dt is the rate of change of flux. So this is all about self-inductance. And from this we can write what is self-inductance. The negative sign indicates that the EMF induced is opposite to the flow of flux causing it. This is Lenz's law. The induced EMF is also proportional to rate of change of current causing the flux phi. That is E directly proportional to di by dt and a proportionality constant L is added here. This L is called self-inductance of the coil. Here also the negative sign indicates that EMF induced is opposite to the current causing it. So equating the two equations L into di by dt, which is equal to n into d phi by dt, because both are the induced EMF. And from this we can get L is equal to n into d phi by di. So self-inductance L is equal to n into d phi by di. If the permeability is constant, then we can write that L is equal to n into phi by I. And coming to mutual inductance, the mutual inductance is defined as the ability of one coil to produce EMF in the other coil by induction when the current in the first coil changes. So see, the two coils are placed nearby. So the current flowing through the first coil induces an EMF in the neighboring coil. This is due to the mutual inductance. It is also defined as the Weber turns in one coil per ampere current in the other coil. It is measured in Henry. And the mutual inductance value is given by M is equal to N2 into d phi 12 divided by di1. So for constant permeability, M is equal to N2 phi 12 by I1. So this is for one coil. If the current flowing through the coil, if we take the second coil and again the mutual inductance M becomes M is equal to N1 d phi 21 divided by di2. This M is because of I2 and the previous one which we have seen is because of the current I1 in the second coil. This is all about mutual inductance, self-inductance and coupled coils. Thank you.